the last session, we have seen how to create interface, how to create nested interfaces, some properties of interface and all, right? So today we are going to see nested interface example also in complete way, and we will see how to call these different methods, how to call these, create the object of how to instantiate this particular interface and all those things, how to create object that we are going to see now. Okay. So first, as I said, interface is nothing but it's a pure abstract class itself, right? So it is an abstract class. It doesn't have any constructors, anything. And as we know that abstract classes instantiation is not possible, we cannot create direct object of any abstract class. Similarly, we cannot create object directly of an interface as well. So how to create the object? You can create the object which is of the class who is implementing this interface. Okay, you can create the object of the class which is implementing that interface. So here we will create the object of class demo IMPL, which is implementing demo interface. Okay, so in the main method, here we will create object of demo IMPL G is equals to new demo IMPL. As it is in class, there is by default constructor gets called we by the JVM. You can create a constructor also if you want. Okay, so that is totally up to you. If you want, you can create the constructor. If you don't want, don't create the constructor. Then by default constructor, that is default constructor, will get called or created by the JVM. Now, this is class object, right? So you can call class methods, that is display method, and you can call the display overloaded method where you can pass the string object. So here I am passing the string value. This is example of overloaded display method. Okay. Now we will execute this. You can see the output. So display method of demo IMPL class is called. Value for the institute, we have just access the final variable, static final variable from our demo interface in the demo IMPL class. Okay, so that is why I'm displaying this value of institute variable, and this is the overloaded string display method with the string parameter that also we have covered. Okay, so we are creating direct object of the class. Similarly, now this is an abstract class which is implementing demo interface. But this is an abstract class, so you cannot create direct object of it, right? You can create a reference of it, or you can create the class which is extending this abstract class and extending this abstract class object directly. Okay, that is child demo IMPL1. You can create the object of this class and call the method. So I am using this class to create object. C is equals to new child IMPL constructor. As it is a class, you can call all the methods as c.display. So we have implemented only display method inside this child demo IMPL class, right? But there is a parent class which is demo IMPL1, which is abstract, and it has one method that is string display method itself with the string parameter, right? So you can call the parent method as well here using this child object. So I'm passing here. This is display method. This is display method from parent abstract class. Name of the class is demo IMPL1. Okay, so I'm using this statement to display the string. We will execute. So you can see this display method of child IMPL1 is called, and the display string s method of the demo IMPL1 is called, and whatever the string we have passed, that is I am displaying here. Okay, so this is the another way. That means you can use the implementation classes which you have, which is basically implementing an interface, or if that is abstract class, you can use the child class, which is extending that abstract class to create the object. Similarly, using the upcasting concept, you can create the class, interface reference or abstract class reference as well. So here I am showing you interface reference first. So you can use demo d is equals to, you cannot instantiate it using new keyword. So if you want to instantiate using the upcasting concept, you have to use the child class implementation, that is demo IMPL1. Or demo IMPL, okay? Same name. D I have already given, so I am creating the D1 reference, and you can call the methods same as previous, okay? So basically, you can use D1.display, D1.display with string parameter, calling display method, calling display method using interface reference. Okay, interface reference. So this is, in this way you can use the interface reference just same as we are creating the abstract class reference. Similarly, we can create the interface reference, and you can initialize it through the child class, which is implementing that interface. It is nothing but the inheritance concept itself, right? So we have seen this in the upcasting. The same upcasting you can use here for creating this reference variable. You can create it and you can use it. Okay. Then this is the one way again. So we will execute this, saving and executing. So you can see the demo IMPL, we have initialized it through demo IMPL class itself, right? So now this is third way. You can directly use this classes object initialization, or you can use interface reference and use the class which is implementing that interface. Okay. Now here we have seen this creation also. Now we have created the extended interfaces, that is show interface, which extends demo interface, sing interface, which is showing you multiple inheritance, which is extending multiple interfaces. And we have created this implementation class for implementing these particular interface, that is sing. And we have implemented all these methods from the parent one also. So we can create the implementation reference or implementation class object I is equals to new implementation, and you can call all the methods using this object, that is display method I dot display with overloaded string parameter. Here I am passing display method of implementation implementation class, implementing all methods from parent references. Interfaces I will use. Okay, there are multiple interfaces as parent. That's why I'm writing this parent interfaces. Okay, now you can call the other methods also, which we have implemented here. That is show method, sing method, I.sing method is there. Okay, so all these methods we have implemented in the implementation class, and this implementation class is basically implementing the sing interface, which is inherited from these two interfaces. Okay, so here we have seen the inheritance concept, that is multiple inheritance, and how to provide the implementation to this. If you can provide the implementation to this show itself only, then the demo interfaces methods also you need to give implementation. That means in the demo we have given two methods, display and the overloaded display method. So those will also get included in the implementation class. Okay, we will execute this. So you can see display method implementation class. This is also implementation classes method, and whatever I have written given as an input to this method, that is display. Show method and sing method also of the implementation class. So for these, this is an implementation class. Okay, for implementing sing interface, you can create sing interface reference also and store it into or initialize it through implementation class also. So I will use sing as reference and I'm implementing it through implementation class object. Same as previous. Here I am calling only a single method using this s dot sing. Okay, s dot sing I am calling here. So this is also one way. Now, sing interface has parent interfaces. There are two parent interfaces, right? So show and demo. So you can create a reference through these also. For example, here I can create directly demo reference D2 is equals to new implementation class. You can create, you can initialize it through implementation class as well. Okay, and you can call the methods. Now here you can see as it is the demo reference, it doesn't have all the methods. Okay, implementation, though you are using the implementation class object, sing here we are using interface reference. So sing has inherited other methods as well. That's why all the methods are available here, like s.sing, s.show, s.display as well. Okay, so all these methods are available because these are inherited from its parent demo and show, right? But demo interface is a very parent interface. That is, you can say, a grandparent interface. It doesn't have all these methods. As it is a parent, it will only have its own methods, that is display and the overloaded display method. So you can only call those methods, that is display method or the display with overloaded string parameter method. Okay. Similarly, if you are using show interfaces reference and creating implementation object, then the parent interfaces method accepts sing method, that is show method, and its parent interfaces, that is display methods, will also available. So here you can call its own method, that is show method, and you can call its display method Object is S1 also. Okay. So this is the way where you can create references of interfaces in different ways. So if there is an extended interface, you can use parent interface reference also. You can use its implementation class object also. You can create implementation class object also. You can use its parent interface reference. If any interface is extending more than one interfaces, so you can use either one reference to create and instantiate this, but you have to instantiate it through the implementation class only. Okay, now I will execute this. So you can see the sing method of implementation class, show is also called, display is also called, and show and display we have seen this in a different ways. Okay, now if you don't want to create any class, implementation class, then as we have used anonymous class anonymous class concept to provide the implementation of the abstract class methods. Similarly, this concept you can use for providing implementation to the methods of interfaces also. Okay, if you don't want to create a separate class, then you can use anonymous class to provide the implementation to the methods of that particular interface. Then how to create? So you have to first create the interface reference. So suppose I am creating the reference for show interface itself, that is S2 reference. Now here I am using new keyword and I am initializing it through show constructor. I am calling the show constructor. After that, this code is added. Okay, this code is implemented here, which is basically overriding all the methods from its parent interface, that is display, and the show method, which is its own method of the show interface. Okay, so you can provide the implementation to all these methods and you can call it using this particular reference, that is S2 dot. You can call display method. You can call show method, anything you want. So here I am giving some implementation, that is system.out.println. Display method, implementation using anonymous inner class. And whatever the string we are passing here, that I will append. Same statement I am adding here using anonymous inner class, but we don't have any parameters. I am just removing this parameter. I have already called this method using the same reference, that is S2 reference. Okay, S2 dot display. So we will get the output of the display method directly. So here we are basically creating anonymous inner class. Anonymous inner class name is decided by the compiler and all those things. We have seen the properties of the anonymous classes previously. So this is the example of anonymous class. Okay, understood? So you can use the anonymous inner class to provide the implementation of the methods of interfaces as well as abstract classes without creating a separate implementation class. Clear? Understood? Once again, go through this different ways of creating object or instantiating this particular interfaces concept. Then we will see how to access the nested interfaces. Any doubt, anyone? Till here, anyone has any doubt? Clear with this, right? Okay. Now, next point is we have seen what is nested interfaces. Nested interfaces is nothing but you can create an interface inside a class or inside another interface that is known as nested interfaces. So this interface is outer interface and this interface is inner interface. This is inner interface and this is outer interface. Okay. Now, we will see how to provide the implementation to all this, as well as how to instantiate this, how to access the members of this inner interfaces using outer interface reference. Okay. So for that, I am creating another class because this is an interface file itself. The Java file is for interface itself. You can create inside an interface, you cannot create the main method. The main method should always be created inside class. Okay. So that is why I need to create another class in interfaces itself. I'm creating another class. The name of the class I'm giving as nested interfaces demo. Okay, including the main method. So in this way, you can create in separate files also. In separate Java files, you can create the interface, you can create your uh, class also. Okay. Now here, first, this class needs to implement this particular interface. Okay. Which interface? Nested interface is the name of our interface. Okay. So here I am you can use the same and main method should also be in the same class, or you can create a separate implementation class if you want. Okay, now I'm going to show you this separate class. Nested interface implementation class, which implements what is the name of the interface? That is nested interface. Okay. Now this nested interface has methods which are unimplemented. So this is an unimplemented method, that is display method. So you can see this nested interface has display method and it has show interface also. So if you want to provide the implementation to show interface, then you can use, first we will give the implementation to this display method. Okay. So here I am writing one statement just to understand. Display method of nested interface implemented. Okay. Now, if I want to give implementation to this particular show interfaces show method as well, then we have to access this show using the outer interface name itself. Okay. So as you know, class can implement multiple interfaces at a time. Okay. Class can implement multiple interfaces. That is why you can say that here we can class can extend only one class, but it can implement multiple interfaces at a time. So here I am using nested interface, comma, Second interface we have to access through the outer interface itself, that is nested interface dot show. As it is a member, you have to access it using the dot operator. Same as the normal class variables we access, class methods we access, in a similar way, you need to access it as a member of the interface using dot operator, and then you can provide the implementation to this show method. Until and unless you are not implementing this particular inner interface, the method implementation will not occur. Okay, it will not get added by default in your class implementation. Okay, so if you want to provide the implementation to the inner interfaces methods, you have to access it using the outer interface name and dot the inner interface name. Okay, so here I am using same statement. I am changing this show method of nested interface, the name of it show interface. Show inner interface, I will write implemented. Okay, this is how we implement. Now you can directly create the object of this implementation class, right? And you can access it like this new, and you can call the method display and end dot show method. Okay, this is one way. You can access it, you can provide the implementation in this way as well. Second way is you can provide the implementation using anonymous inner classes directly without creating the implementation class. Suppose here I am using, now you cannot access directly the inner interface. Okay, you cannot access directly the inner interface, as we have already this show interfaces imported from, this show interfaces actually taking from your interface example where we have just created the show interface with the public accessibility. That is, not public, default accessibility, that is package level accessibility. So it is taking that, but I don't want to give the implementation to this show interface. I want to give the implementation to nested interfaces show interface. Okay, then if you want to access that, you just need to use nested interface dot show. Okay, and then the implementation will change here. Using nested interfaces IMPL class, which we have created just, which is implementing this class. Now it is taking this. I have imported this. Okay. By default, it is imported the show interface here. You can access now the show interface from your nested interfaces itself. Okay. You can use this implementation class, or you can provide the implementation using anonymous inner class. And this way. Okay. So here we are using different ways to initialize object, instantiate any object using anonymous inner class, show method of show inner interface implemented using anonymous inner class. Okay. So this is how you can access the inner interface also, as this is not the private interface, but you can create the interface as private, not private, protected default accessibility, you can give it. Okay, you have, if you are creating it as public outer interface should never have the public inner interface, you can use. Okay, but when you are creating the public classes, nested classes, that time public class should be saved in a separate files. So that's why we consider it not creating nested classes as public, but you can create the nested interfaces as public. Okay, now you can call this show method using this reference. That is s dot show. Save it. We will execute. Okay, the show method of inner interface implemented using anonymous inner class. Similar way, you can instantiate or you can create the reference of outer interface as well. That is nested interface is equals to new nested interface. Then the implementation using anonymous inner class and add an implemented method. So nested interface has its own display method itself. So here only display method is overloaded, added. Okay, you can call it using the reference which we have created ni.display. So here we are not able to add the show interfaces method or override the show interface method because that interface is inner interface. But you can do in this way also. You can use this reference and you can provide the implementation to show inside this anonymous inner class as well. Okay, and you can use that particular reference to call it here. You cannot call it here. So suppose you try this ni dot show is not available here. Okay, show is a part of only the anonymous inner class, this anonymous inner class. That's why you have to call that using this s1 object here itself or s1 reference. S1 dot show. One second. Not taking this. What is this actually? I will save this first because it is not taking. File. So it provides some implementation here. System without the println. Display method. Of outer interface. Outer nested interface implemented using anonymous inner class. And here for the show, system without the println. Show method of inner interface implemented inside anonymous inner class. Save. Okay. Now we will try to access this. Swan dot is not taken. We'll try here. Ni dot swan. It's not calling this show method. I need to check this because I have used the same syntax, but still it is not taking. I will see and I will let you know. Okay, we will execute till here. Okay, so this is the display method of nested interface, outer interface created using or implemented using anonymous inner class. Okay, so here in this anonymous inner class, I am creating this, but you don't need to do that. You can do it outside of this anonymous inner class also. There is no need of providing the implementation inside an anonymous inner class, basically. That's why it is, the code is correct, but there is no need of doing this. You can separately provide the implementation like this. But if you are using the interface, that is the inner interface, you have to import that first. Okay, because it is an inner member and this has the public accessibility. I have changed the accessibility. If it has the default accessibility, it cannot be imported outside of the same package. Okay, so this is all about basic interface concepts where we have seen the properties, how to instantiate the interfaces, how the nested interface works, how the extended interface works, all those things. Anyone has any doubt in this? Clear with these concepts, right? Basic interface concepts. We have already seen the difference between class and interface in the yesterday's session. So today we are going to see the difference between abstract class and interface. That is a notable difference is there between the abstract class and interface. Through both, we can achieve the abstraction. But there are few differences. First difference is abstract class contains concrete methods, also contains concrete methods, abstract methods and concrete methods. And interface only contain the abstract methods. But now after JDK 8 version, concrete methods are also allowed. So this difference you can see till JDK 7 version. Okay. Same for the second difference, that is, it is partially implemented and it is full abstract. This difference is also till the JDK 7 version. From JDK 8, interface has concrete methods. Then we cannot create the instance of abstract class, or if abstract class can have instance variables and constructors, but interface never have the instance variables and constructors. It will have final, static final variables, final and static separately, as well as final static together, that is constant variables. But interface will only have public static final variables. Okay. Then class abstract methods explicitly declared as abstract, and interface methods are by default abstract. We are not writing anywhere abstract keyword while declaring the methods inside an interface. So these are implicitly abstract or by default abstract. So here abstract methods can be declared as protected, default and public. But in interface, these methods are by default public. Okay, that means it has the public accessibility. So other modifiers you cannot be used. Okay. Then class extends abstract class. Any class can extend abstract class, and a class implements interface. Class can implement multiple interfaces. A class can extend only one abstract class because a single inheritance is possible through classes and multiple inheritance is possible through interfaces. So a class can implement more than one interfaces. Variables must be explicitly declared, public, final, or static if needed. Interface variables are by default public, static, final. Okay, these are few differences between abstract class and interface. So how you can achieve the multiple inheritance through this interfaces that we will see. So what was the problem? That is a diamond access problem. When we have discussed that the multiple inheritance in classes, that is basically multiple inheritance has, if there are more than one parent class for a single child class, and suppose it has same methods, then the compiler will get confused which method to call, because there is a diamond access problem or ambiguity problem because of the same name. But here, if you are creating any interfaces, so okay, I will show you the example. Multiple interface, multiple inheritance through interfaces. Including the main method. Now we will see how can we use the multiple inheritance concept here in this particular interface concept. Okay, so now this I will create one interface. Suppose that interface name is print. Okay, and this interface has one method, print itself. Okay, sorry. Void print is the method, which is public abstract method, right? Similar to this, I will create one more method. Suppose the method is void sing. So interface print has two methods, print and sing. Now I'm creating another interface. Interface name is, suppose, show. We have already taken that name. So I'm using dance. Okay. Interface name is dance. It has the void dance method, as well as this method will have the same method, that is print method. Same name. Okay. It also has the same method name, that is print. Okay. Now we can create a separate class or one interface. We have already created the interface. It has which is taking this, but we will create one more interface here. Suppose the interface name is print data. Interfaces print data, which is extending print interface as well as this dance interface. And it has its own method. Suppose that method is void print data. Okay, the method is print data. So we have created three different interfaces. This two interface has the same name of the method, and here we are extending this print and dance together, but we are not getting any error here. Why? Because these two methods are abstract methods. There is no body for this method, and that is why in this interface you can achieve the multiple inheritance through this if there are same method names present in our interfaces as well. Okay, so though we have same name for the methods, still you can extend those methods as those are abstract methods and there is no implementation provided. So if you want to provide the implementation, suppose we will create a class. Now this class I'm using the same, which is implements the print data interface. So we can add all the unimplemented methods. in unimplemented methods are. So you can see print is there only once. Okay, so it is taken as common. Okay, दोनों में से एक ही, दोनों अलग अलग नहीं कंसिडर किया है. A single print method is here for giving an implementation. So you can, though we have multiple methods or same name methods, we are providing the implementation to only one method. Okay, and you can call it using the references created or the implementation class object also. So here I am simply using system.out.println print method. You can change the implementation if you want. I am simply showing you how this gets called: sing method, dance method, and print data. Okay, which method is called, that is I am only explaining here. And in the same main method, now all these are instance methods. So you have to create the object of this particular class, then you can access it, or you can use the reference of the interface also. So here you can call dance method m dot print method, m dot print data method, m dot sing method. Okay, all the methods using the implementation class, or you can use the print data reference and you can use the implementation class, which is object. Now this will have all the methods. So you can use p.dance, p.print, p.print data, and p.sing. Okay. I'm writing this code at the end. Okay. So here we are using the same implementation class for creating the object, instantiating this print data. In the last example, we have created the other interface reference also. So you can create the parent interface reference as well. If you are using the dance interface reference, you can access only dance and print method. You cannot access this print data method or the sing method. So I will show you that also. If we are creating the dance reference and implementing the object of implementation class, so you can call its own dance method, then print method itself, but you cannot call the print data method and sing method, because sing method is in the print interface and print data is in the print data interface, which is child interface, right? So if you are using the parent reference, you can only access the parent members. Okay, I will execute this. You can see this is for the first, this is for the second object, and this is for the third object. That is third reference, dance reference. If you want to get it clarified, you can add statements here before calling the methods. System.out.println. Implementation class object. Then we have created this implementation class object using print data interface reference. And the last one is implementation class object using parent dance interface reference. I'm adding these lines just to understand the output. I will execute one more time. So you can see the output now. This is, we have created the object directly and called the methods. This is, we have created the print data reference and called the methods. We are getting all the methods. And this is a parent dance interface reference, but we got only 2 methods access because dance has only 2 methods. Okay. So though we have same method names in our interfaces, we can extend it in a third interface. That is, a multiple inheritance is possible through interfaces in this way. But multiple inheritance is not possible through classes. Why? Because of diamond access problem or ambiguity problem. Clear?
So, ma'am, overall abstract classes and interfaces objects cannot be created. So that's why we are instantiating with the class.
Yes.
Okay. And here, I'm not able to understand this print function, which is the part of this print interface, as well as print function is there in dance also.
Yes.
So if I'm extending the class, sorry, if I'm implementing this dance as well as print, right? So how it is going to differentiate this print and this print?
So there is no differentiation because there is no body for this. The name of the method is same. Okay. So whenever we are implementing that interface, whatever the print method implementation we are providing, that will become your implementation for that method, right? Because here there is no implementation. This is just the name of the method.
Correct. So both the print are having one definition that you have written here. System.out.println.
Yes, both print will have the same implementation.
Okay.
There is no difference between the interface print and
I cannot give print.print, dance.print. No.
No.
Okay.
So because here in this example, you can see that we have a class A. It has a display method. We are providing some implementation to it, right? There is a class B.
Correct.
We avoid display method. We are providing some implementation to it.
Correct.
But when we are trying to extend the class A and B together in the class C, it will not take because multiple inheritance is not possible in classes because it has the display method. So if you are calling this c.display, though you are creating the object and you are calling the display method, the compiler will get confused which display method implementation should it call, whether it is class A or class B, right? So that is why this is not possible through classes. But in interfaces, we have not provided any implementation. It is just a name of a method we are defining. Okay. So you can have n number of interfaces which has same name of the method. But whenever you are providing the implementation to that method, that will be the implementation for that particular method, right? So that is why, though you are not creating this interface here and you are implementing dance interface, so you are basically providing implementation to dance and print method. So that method will get called through the dance interface or that implementation class. But what I want to show you here, that multiple inheritance, that means whatever the class A and B was not taking here as extends after extends keyword, we can do that here in interface. The multiple inheritance is possible. We can extend multiple interfaces, though these interfaces have the same method names.
Okay. So is there any types like implicit, explicit? No. In Java?
I don't understand your questions.
No, like implicit interfaces and explicit interfaces. Usually implicit means what? Directly we can give the function name or method name, right? And explicit means how the way we are having dance.print. Like that, we are having explicit way in which the interface name will be mentioned.
No, here we don't need to do that. We can directly access the members of this interface by using any implementation, whatever the implements, after implements keyword, whatever the implementation you are providing for that interface, whichever interface. Okay, what if you here instead of print data, you are providing implementation to only dance. So only these two methods will appear, print and dance. Okay, according to your need, you are using the implements keyword, and for which interface you want to provide implementation, you can mention that. That is the only thing. You don't have to access it using the interface names.
So this print function is print function system.out.println print. So this particular thing is going to appear for both the interfaces print method.
Yes.
Okay.
Both interfaces. So here
I cannot write it separately.
No, you don't have to write it separately because the implementation is same for both. Okay. So here we have created the dance reference and you're calling this print method. Okay, because dance has print method. So we are getting the same output print, right? So suppose same in a similar way, I am trying to create the reference for print T is the reference. Okay. Here I am using print parent interface and I'm calling T dot. Now the dance method will not be there, right? So T will have only its print method and sing method. So here I am using sing method and print method. So we will have the same output because there is the same implementation for the both method. Okay, the differentiation, there is no different implementation for both the methods. You don't have to do that. It is automatically taken as the same implementation for both the methods, or whatever the number of methods you have, same number. Okay, clear? Because we are providing implementation only once. So it's the same implementation will be appearing for all the methods which has the print method for all the interfaces which you are using as here in the multiple inheritance concept.
Okay, yeah, fine.
Okay, clear? So anyone has any more doubts? Okay, so with this, your basic concepts of interfaces is completed, and your ninth module is completed. So we have already completed the module 10, that is inheritance and polymorphism. So we are going to go forward with the next module, that is 11th module, which has some more parts of the interfaces itself, which has advanced parts of the interfaces, that is the newly added methods, default, static, and private methods that we are going to see in the next module, that is module 11. Okay. Thank you, everyone. We will end our session for today here, and we will continue in the next session with the remaining part of the interfaces.